In this video, you are going to learn about covalent bonds, how they're made, and how they form. Only the noble gases exist naturally as single atoms. All the other elements of the periodic table have partially filled valence shells or outer electron shells. Atoms bond by swapping or sharing electrons in their outer shells. When very different atoms react like metals and nonmetals, they normally swap electrons. This is ionic bonding. When similar atoms react like nonmetals combining with other nonmetals, they share electrons. This is a covalent bond. Nonmetals are found on the right-hand side and upper part of the periodic table. Some common nonmetals are carbon, nitrogen, oxygen, and the halides. They have shells of electrons that are normally half or more than half full of electrons. Since they have a strong attraction for a few additional electrons, it's energetically unfavorable for them to lose electrons. So they share electrons by overlapping orbitals. This makes a bonding orbital or covalent bond that contains two electrons. If there is space in the outer shell, a nonmetal atom can form double or triple bonds like in oxygen or nitrogen. In the displayed formula of a compound, we represent a covalent bond with a straight line like this. We can also represent a covalent bond as a dot and cross diagram. These diagrams show only the valence electrons. Covalent bonds are directional, which means they are in a fixed position, like holding hands. This is different from ionic bonds, which are formed with an electrostatic attraction between charged ions. The overlap between orbitals means that the atoms in covalent bonds are very close. These things make covalent bonds strong. There are two kinds of covalent structures: small molecules like water and giant compounds like diamond. Because the electrons in the bonds are evenly shared, the bonds are not polarized. There's little attraction between molecules and forces between molecules are weak. Compounds made from small covalent molecules have low melting and boiling points and are volatile. They also don't conduct electricity. Carbon and silicon tend to form giant covalent compounds. These bond in the same way, but instead of forming small molecules with one or two bonds, they form four, making up huge lattices or chains of many linked up atoms on the basis of the organic chemistry of carbon or the chemistry of rocks. One common example is a diamond, which is made up of carbon. Each carbon atom forms four covalent bonds because it has four electrons in its outer shell to share and has space for four more. If every carbon atom forms four bonds with four other carbon atoms, and each of these form four bonds with four other carbon atoms, and each of those form four bonds, we're going to very quickly end up with a very large structure. These compounds have very high melting and boiling points because you have to break covalent bonds rather than the intermolecular forces to make them free enough to act as liquids or gases. The covalent bonds hold them rigidly in place in the giant lattice structure. Allotropes of nonmetals bond covalently. Allotropes are different structures of the same element. So, to finish, here's a challenge for you. Which of these compounds is covalent? Pause the video for a moment while you think. Did you consider their physical properties and where the elements come from on the periodic table? Did you solve it? Okay, the answer is all of these compounds are covalent. Carbon dioxide, carbon monoxide, and methanol are all small molecules. Organic molecules form covalent bonds between hydrogen and carbon. C70 is a fullerene, a carbon molecule shaped like a rugby ball closely related to the Buckminster fullerene. Silicon dioxide is a giant covalent structure, and just like diamond, but it has oxygen atoms bridging between 4 coordinated silicon atoms. Hopefully, you now feel confident identifying covalent compounds and recognizing their properties.